So let me start today with a question that was asked in the discussion session. So the setup was the following. So if you know that I is recurrent, then under Pi, whatever we defined as Bn, that was converging almost surely to infinity or diverging almost surely to infinity. And then because of the recurrence of I under Pi by dissection principle, this block sums eta 1, eta 2, etc. were IID with common mean, which is this guy. Then I wrote that combining 1 and 2, we get that if you look at the block mean for a random number, namely Bn many, eta case, this block mean is also converging. I don't say block mean of the block sums. Okay, if you look at this mean of the block sums, but the mean is taken of a random number, namely Bn many eta case, then that also converges to the same quantity. I had just stated it without giving any explanation. And then one of you asked in the discussion session, why is it true? And that's a valid question because this number Bn is random. So the question is how to prove this this hash here. And I'm just going to tell you how to do that at the beginning of this lecture. And that basically what you do is you define an event A, which is the usual mean of eta case converging to its expectation as m goes to infinity. Okay. On the other hand, another event C is the event that Bn, this random variable Bn, diverges to infinity as n goes to infinity. Now it is given that I is recurrent, and therefore from there it follows that Bn diverges to infinity. This is something we discussed last time, because Bn gives the number of times the Markov chain returns to I before time n, and as n goes to infinity, this converges or diverges rather to the total number of returns to I, which is infinity. So therefore, this almost surely goes to infinity, and therefore probability of C under Pi is 1. Similarly, from strong law of large numbers, since under the dissection principle, eta 1, eta 2, up to eta m, all of these guys are IID under Pi. So therefore, this also happens with probability 1 under Pi. So Pi of A is also 1. We also know that if you have two events which have probability 1, then the intersection also will have probability 1. So Pi of A intersection C will also be 1. On the other hand, on the event A intersection C, so this is the event when A happens as well as C happens, we know that if you take this mean of random number of etais, namely Bn many etais, okay, that also converges to the expectation here. Okay. So because here this happens as whenever m goes to infinity, and on C, Bn goes to infinity anyway. So therefore, instead of m, if you have Bn here, this also will go to the right thing as n goes to infinity. So therefore, on the event A intersection C, we will have that this converges to this. And of course, this event has probability 1. So what we are saying is, on an event of probability 1, this intersection holds, this convergence holds, and therefore, this means that this converges almost surely to this quantity. So this completes the proof of hash. So I hope this explains what is going on. If you still have a question, please feel free to ask me. I can try to answer it over email.